Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Find the largest value in each tree row. Leetcode 515. In this problem, we are given root of the binary tree and we have to return an array of the largest value in each row of the tree which is 0 indexed. Then in example 1, for the given tree, there are 3 labels or rows, label 0, label 1 and label 2. And our output consists of the largest number at each label which we will return as a list. So for the first row, there is just one node with value 1 and it will be the largest. Then for the second row, there are two nodes with values 3 and 2 and among them 3 is the greater one, making it the largest value for this row. And finally in the last row, there are three values 5, 3 and 9 is the highest among them. Therefore, we return the result as an array or list where each value is the maximum from each row and here the resulting list will be 1, 3 and 9. Now in terms of solution, if you are new to these type of problems, almost always with binary tree problems, we either use depth first search, abbreviated as DFS, or breadth first search, abbreviated as BFS. Although DFS is more commonly used, in this problem, since we have to find the maximum value at each level, we can use BFS, also known as level order traversal. I have already covered level order traversal level by level. So if you are interested in learning or revising it, please check out the I button. In BFS, we use a queue and we start by adding the root node to the queue. For example, we add node 1 for the current example. Now, as we have to process each level of the tree, we can use queue size to determine the number of nodes at the particular level. And for each level, we will initialize the maximum value with a very small value like minus infinity or the minimum integer value in different programming languages. Then we dequeue the elements one by one and check if each element is maximum for that level. And if the nodes have children, we will enqueue those children to process those in the next level. And this process continues until there are no more nodes to process in the queue. Now let's see this in action. For first row, the queue size is 1. That means we have to process only one node for this level. So we dequeue 1 and since 1 is more than negative infinity, we will set the max for this level to 1 and enqueue its children 3 and 2. And now we are done with this level. So we will add maximum value 1 for this level to our answer. Then for next level, queue size becomes 2. That means we have to now process two nodes at this level. And again we set maximum value to minus infinity. Now we dequeue 3 and we can see that 3 is more than negative infinity. So we will set the maximum value to 3 and enqueue its children 5 and 3 to the queue. Then we dequeue 2 and 2 is less than 3. So our maximum value remains 3 and we enqueue its child 9 back to the queue. And now we are done with this level as well. So we add the maximum value of this level to our answer and continue to the next level. Now the queue size is 3. That means we have to process 3 nodes at this level and we reset the maximum value again to negative infinity. Now we dequeue 5 and 5 is more than negative infinity. So maximum value now will be equal to 5. And since 5 doesn't have any children, we don't enqueue anything and dequeue the next node from the tree, which is 3. And 3 is less than current maximum, that is 5. So maximum value stays 5 only. And again 3 doesn't have any children. So we dequeue 9 and 9 is more than 5. So our maximum value for this level becomes 9. And since 9 also doesn't have any children, we don't enqueue anything. And now we are done with this level. So we will add maximum value 9 to our answer. And now our queue is also empty, indicating that we are done with BFS as well. And finally, this will be our answer. Now let's jump into the code part. First, let's initialize an empty list to store the largest value at each level. If the root is null, that is, tree is empty, we will return the empty answer list. Otherwise, let's initialize queue to perform level order or BFS traversal. We can use linked list implementation in Java for that. Let's add root node to the queue. Now we will start the BFS. So while queue is not empty, get the current size of the queue, indicating number of nodes at the current level. Let's initialize the maximum value to smallest possible integer value. Now for each node at the current level, we will dequeue the node and update the max value for the current level to the node's value if the node's value is greater than current max value. And if the node has left and right children, we will add them to the queue. And once we are done with this level, we will add the maximum value for this level to our answer list. And finally, once the queue is empty, we are done with BFS, so we will return our answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is number of nodes in the tree. Because we are traversing through each node only once by adding it to the queue and then removing it. And in terms of space complexity also, it will be O of n, because we are using this queue to store these elements, and in the worst case, for example, for the completely filled binary tree, the last level will contain n by 2 nodes, and at any point queue is storing the nodes from at most 2 levels, which is still proportional to n. So the space complexity is O of n. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.